All right. Welcome back to the session, students. Good evening to all of you. Yes, I hope you all can hear and see me. Can I get some comments? Let us check the live chat. I'll just quickly access the chat, students. Just give me a minute. Perfect. All right. Hi. So, welcome back to the session, students. We will continue on the day 3 of our DSA with C++. Now, the idea here is that today we will start off with understanding few of the loops that we are supposed to do, and then continue with the session and talk about arrays, what is dynamic memory, how to allocate it, and a few more things in the line, right? So let us start off with understanding a few basic loops, one of which is while loop. So yesterday we have looked into the if-else loop, we looked into the uh, primarily the switch statements, how switch is supposed to work, right? So we'll quickly jump into and analyze one of the another loop known as while loop. For this, let me just remove the string and let me use namespace as standard again. I hope my voice is clear and you all can hear me correctly. You can just put it in the chat if my voice is clear and you can hear me. Okay. So we will go back and introduce one of the variable integer, say I, which is equals to 0 at this point. Let us say we will start with the while loop. So what while loop is supposed to do is that while loop takes in your input condition and it executes that part of the code until and unless that condition is true. Okay. So while the given expression, while the given condition is satisfied, the loop will never stop, which is why it becomes extremely important and crucial to design a while loop which can handle a deadlock, which means that if I'm a developer and I'm writing a code, I need to definitely make sure that the while loop which I'm giving an expression to has an end to it, right? If the while loop never ends, we are stuck in something known as infinity loop or infinite loop, right? So that you will never get out of the loop. Let us understand how does it look like. So while I do while, so while my I is less than maybe 5 for an example, I'll open the brackets. So this is the syntax again. You all know the syntax for any conditional statement for loop, while loop is same that you write the loop name. In the round brackets, you put in the expression, and in the curly braces, you give your piece of the block that should be executed while this loop is true. So on line number 5, we all can see that our integer I equals to 0. And line number 6, we start the loop with a condition that I should be less than 5, which is true in our case at this point. I can see out the value of I and also add a next line. And if I run this loop in the same condition as it is right now, it will reach into something known as infinite loop, right? Because for I will forever be less than 5 because I is just 0. But inside the loop, if I add an incremental operator, which is equals to I plus plus. I plus plus is again a shortcut of writing this. I is equals to I plus 1. Okay, which means in the current value of the I, please add plus 1 or add 1 to it, right? So currently I is 0, so 0 plus 1 will become 1, by which the value of I will now be 1. Next time when the loop starts, the value will start from 1. Is 1 still less than 5? Yes, it will enter the loop. It will become 2, and then it will go on like that. 3, 4, until unless it reaches 4, right? Because in the fourth loop, in the fourth iteration, I will be incremented by 1 to turn out to be 5, and 5 is not less than 5, right? Hence, this code will end over there. Let us just quickly run this function once. In the terminal, we must see 0, 1, 2, 3, 4. That's the output that we are seeing in the terminal right over here. You can see I'll highlight it, and it means that yes, the while loop logic works the way we think it should work, right? So that's mostly about the while loop, and I hope it explains you the concept of how it is supposed to work. Now, in the C++, there are a few statements which can help you break early from a loop to save computational memory, right? Or to optimize the code. For example, I'll give you one very simple real world example. Suppose that we are supposed to find an object from a box. This box contains a lot of objects. Okay, a lot of objects are in this box. We just need to find something from it. I'll start removing objects one by one from this box. Okay. Now, I picked up the first object. Is it something that I want? No. Okay, no problem. Remove the second object. Something that I want? No. Maybe. Say for an example, at the fourth iteration, I found that I was looking for the object that I was looking for. Now it doesn't make sense anymore to keep this object aside and keep on digging further until and unless I have removed all the objects from this box, right? It is waste of time. It is waste of memory and uh, time both, right? Similar should be the case in our loops. For example, we are talking about an array which holds roll number of different students. If I'm particularly looking for a roll number 37 and have found it using a for loop that for roll numbers in this array, if roll number is equals to 37, if that I've found it, then I can break out of this loop, right? For example, let us understand how break can work. I'll simply add a for loop for integer I equals to 0 uh, while I is less than 10. I'm just creating an iteration. I is incremented. Okay. If I equal to 4, okay, see out, found our object, now breaking the loop. Okay, this is the output. While we mentioned that object is equals to I slash n, and here we will do see out object is equals to I slash n. Let us run this loop once. Just for a second, let us remove this from the for loop and put it right over here. So you can see that we are finding just the object, and let us go over here, iterate from here. Okay, as you can see that if I put the object equal to, it starts from 0, goes to 1, 2, 3, 4, and when object equals to 4, it specially prints that we have found the object what we were looking for, right? Let me also add a slash n over here. Let me run this loop once again. So now you will see that object equals to 0. This is not what we were looking for, not even 1, not even 2, 3. 4 is something that we were looking for. And it mentions found our object that we were looking for. Now breaking the loop, right? But it didn't break because there's no break statement right now in this code. And if you look object 5, 6, 7, 8, 9, it kept on searching even after finding what it was looking for. So the idea is if we have found what we needed, we should break the statement. And now if we try to run this code, you will realize that on finding our object, there is no more further iteration that it goes on looking into object number 5, 6, 7, 8, 9, right? Because that's not needed. So that's the idea of how you can use a break statement to do something about it, right? Whereas there is also known as a continue statement. So what is the use of continue statement? Let's look into it. Let us say that there are few roll numbers in our classroom which have failed the examination, or we need to pass a special message to these people, right? So what will happen is we're iterating to the classroom. We are writing a program which will digitally send the mark sheet to all the students via email, right? So we will start a for loop that for students in our list, uh, find the student name and then send this mark sheet to student. But if the roll number is special is equals to some special case, like say roll number 20 or roll number 30 or a group of roll numbers, like if the roll number is in 20, 25, 30, 47, then in that case, there is a special thing to be done. In that case, shoot one more email with some remarks, but keep on continuing your looping, right? That's where continue statements come into picture, right? So, for example, you will see that it went into our loop. It definitely went into our loop, and continue is just by making sure that you do not break anything, but you continue even after doing this, right? So that's the idea of how to use continue statement. Now, once this is done, the next idea is we should start looking into arrays. Okay, what are arrays? So arrays is something that is used to store multiple values in a single variable, right? For example, if I have to store something, say a is equals to 10. Okay, ideally in C++ we write integer. A is equals to 10, integer b is equals to 20. Since I'm writing them below the main function, that's a little bit of issue. Let's write it over here. And integer say c is equals to 30. Rather than see, the idea is a variable can store a value, and if I have to store multiple numbers, the better idea is that I can use an array, right? So array is used to store multiple values. So for example, if I have to declare an array, say array 1, so array starts with the syntax is a data type. I'll mention the syntax over here. Syntax of arrays, data type, space, name, with a round bracket, the size of the array, how many elements will it store, equal to, you can say for now, you can just declare, if you have to just declare the array, this is more than enough. But you have to assign the values, you can do something like this, that data type, name, size, equal to values, right? They go with commas. So that's the idea, that how do you declare arrays and also initialize them and declare them in the same code. So we'll start with an array, like integer array 1. Let's say it will hold 4 elements, and we'll put elements into it, say 1, 2, 3, 4. Okay. So basically what is happening is integer is defining the data type of the array. Array 1 is the name of the array. The value that it holds is the size, how much quantity will it hold, and equal to curly braces are the values which it's supposed to hold. So this is the way to declare an array. Now, how do we access elements from an array, right? So I'll also show you that. Let's go back to our main function. Suppose we create a string of maybe Indian cars, or say compact SUVs, is equals to maybe the size of this array is say 3 at this point. It is Kia Sonet. Then we have Nexon, and then we have XUV 300. Okay. So these are three different categories which are available. Now I have to print or access the elements which are there in the array. So this can be achieved by indexing, right? So the values which are stored in array, they're stored with the index, right? Which can help you locate the value at a particular index. For example, we always start with zeroth number. So the first element of an array is always stored at zeroth index. So in our case, if I find compact SUV at 0, I will find Sonnet. Compact SUV at 1, I will find Nexon. Compact SUV at 2, I'll find XUV 300. So that's the idea. And remember always that the length of the array can always be defined when we are doing it, because these are static arrays. Soon we will talk about the things like dynamic arrays. And yes, of course, let us include string. Even if I do not include it, for now it is compiled, so it might work. But hashtag include string. Okay. So these are how you access. So let us print out the first index. Printing the first value is equals to, and we go for compact SUVs at 0, semicolon, and let us say return 0. Let's run this function and we will realize that we were just able to print the first value equals to Sonnet, right? This is how you can access the values of the array. And how about if we have to change the value? How about if I have to say compact SUVs at 0 should be now equal to, let us have a very good name of any compact SUV. Students, would you like to name a compact SUV quickly in the chat? Let us see. Let us see. I have one in my mind, but let us see if students can put it in the chat quickly. How many of you can go interactive? Let us wait if there is anyone coming in. Well, Creta could be full size SUV above 4 meter, but we can definitely go with its sibling, or yeah, Franks works. So let us go with Franks. And now we go ahead and again see out this same value. And now let us check. Okay, I should add a slash n to print these things on different strings. There you go. Yep. So even addressing the same index, we are getting different values. That is not something unique. It is how you change the index values, right? So now if you try to print compact SUVs at 0th index, Sonnet has been replaced by Franks. Okay. So great. I think like this is how you will understand how to play around with the arrays and how to do things here and there. We can also loop in through the arrays. Yeah. So the issue is that whenever we do any live streaming, be it on YouTube, be it even on your local infrastructure, even on CCTV cameras, so even CCTV feeds or these feeds that we see, they usually have a network lag, right? So the cables can also can have a limit. So 2-3 seconds of lag in offline feed, and 6 to 7 second lags is common in an online transmission, right? So whatever I am doing here and whatever you're seeing, this goes with a 7 second of lag. Okay. So if I click this or I snap my fingers at this point, it reaches you after 7 seconds. So there always be a little lag. I don't know what you were talking about. Sometimes the chat doesn't load. That's a different bug, I think. I couldn't just interpret it correctly, but that's a different bug. I thought someone was saying lag. Okay. Now coming back, let's loop in through all these values. So in order to loop into these values, basically, if I was doing a dynamic array, which we will soon come to, I will tell you how to loop into it, right? So integer I is equals to 0, and this is the start point. Dekho, an array will always start with index value 0, but where it will end, it is not the ideal way to write number 3 over here, because this is just particularly for this case. Okay, if you are designing static solutions, if your solutions will remain static, then it is fine to even place a number over here. But this is more hard coding to make it more agile, to make it more compatible to the change in the dynamics of the code. You should write get size of or size of. Okay, so size of is the correct way to find the size of compact SUVs divided by the size of uh, compact SUVs at 0th index. Now, why I've written it like this, I'll explain you. Basically, compact SUV holds strings, three different objects. Each string has its own size, right? मतलब unique size होता है. So it is finding the size of one single string object, right? So size of compact SUVs is size of all three. Like मान लो अगर एक string 10, like एक string object takes 10 bytes. Just for an example बता रहा हूँ. तो इसमें तीन objects हैं. It will take 30 bytes. So 30 divided by 10 will give you again the idea that how much is the size of one single of it, right? Well, I was just trying to give you a little mathematical idea, but I hope that's clear. But we can for now proceed with 3. That's fine. Okay, while I equals to 0 and I is less than 3, less than 3 क्यों? Because 0, 1, 2 is the indexing. 3, there is no value on 3, right? Hence we'll go here. Or else we would have said less than equal to 2. Both will work. So I've given you many variations that how you can design or decide the ending value of your array. Keep on increasing I by +1. And while doing it, keep on printing cout compact SUVs at I /n. Let us run this now quickly. So as we run it, we see Sonnet next on XUV coming in, looping that. So that's how you loop through arrays. Now, how do you basically look into different things on arrays? Is one is looping, one is adding things, one is omitting certain elements, right? So let's look at, can we declare arrays without defining the size right over here, right? Is it possible? Is it even possible? Let us check that. So I will design once again one array, and I'll not mention the size over here, right? And I'll just return 0. Let us see if this throws us any error. We are compiling and successfully executed. There is no error in this code. The reason is that the compiler is smart enough to learn or understand during the time of compilation that even if you missed to write the number over here, it will automatically check what are the values coming in. And it will say, okay, okay, I understand that these are 3 different values. I'll take the size as 3. I'll do it myself. Now, what if I do something like this? Check it out, okay? Control X. I'll just initialize the array. And now I will declare things into it, right? Say like this. So compact SUV at 0th index is equals to Sonnet, while compact SUV is at first index equals to Nexon, whereas compact SUV is at second index is equal to XUV 300 and return 0. No errors, no issues, things running fine. Now what if I miss the declaration of the size of the array? And now when I hit it, error, error, error. Array size missing in compact SUVs. Incomplete type, error, this cannot be compiled. Okay. What does it mean that I cannot initialize empty arrays if they are static? I have to define the size. Now, why is this the nature is because of how C++ handles memory allocation. See, what is the advantage of using a static array is that you can predefine the amount of memory needed to load this array, right? So at the time of execution, at line number 8, if I'm declaring a static array with a size of 3, the computer program will proceed on line number 9 only after allocating this size in RAM, right? And even if I have not loaded anything into this array, no problem. The size of the array will always remain to its max capacity. Even if I just add sonnet and leave it like at 0th index, it still has size of 2 more things available. Only problem is that in dynamic memory, what is dynamic memory to even begin with? See, when I execute a code, when I'm running it, so while the time it is running, that is known as dynamic memory, right? It is an inference mode. It is the code is now live. It is not stopped at all. Until and as the code is stopped, it is in the dynamic form, right? Or it is in the running mode, inference mode. That is dynamic memory. And during that time, I cannot change the size because if I'm coding something, then I have to rerun the code. And rerunning is again a different concept. We are running the code once again, which means closing the previous iteration and starting a new iteration. So while the iteration is running, that is dynamic memory. And in it, I cannot change the size of it from 3 to 4 now, right? If at all that is my requirement, I should not design a static array in the first place. Okay. So talking about that, if it is compared to be at 0 at Sonnet or anything, then that's how the arrays work for static place. I'll soon talk about the dynamic arrays also. What if I have to create multi-level of multi-dimension of arrays, right? I can still do it. I can suggest that there will be 3 by 3 array, okay? And I can just simply go ahead and do things like this, okay? Is equals to we can go for Tata and then Maruti and then what was it? Kia, comma. We can go for Nexon, comma. We can go for Fronx, comma. We can go for Sonnet. Sounds fair enough. The idea is now we have multi dimensions of array. Okay, so that's a basic idea of how we can design multi dimensions of array. But for now, I'll restrict it to this point that this is how it is supposed to work. Okay, and you can have more complexities any moment in your code wherever it is, right? Now, what is the difference between a static array and a dynamic array? Is that I've explained you that static array is a type of array where memory is fixed and permanently allocated during the compile time, whereas dynamic it can keep on changing the memory in the runtime also, right? So mostly when we are working with dynamic applications, when we are working with applications which are interactive, we choose something known as dynamic array, right? So how do you declare one, right? So for that we have to understand the concept of pointers. देखो pointers क्या होते हैं? Let us quickly understand that, right? So pointers basically ये होते हैं कि for example suppose if I have a variable a is equal to 10, तो a पे आपने क्या रखा हुआ है? 10 की वैल्यू रखी हुई है, right? So ये value 10 it is being stored somewhere, right? It is at the end going somewhere in the memory, right? So how exactly are we supposed to find it? So there is an address in the RAM. Therefore, let us understand RAM is like a large land which is cut into plots. Okay, a large land which is cut into plots, and each plot has a number to it, an address to it, right? You can even understand it to be a building that each building has a very well defined address, street number, tower number, floor number, room number, right? There is a very well defined address to reach any block. So whenever we have to store something in a virtual world, similarly we store it maybe in a permanent memory like hard drives, solid state drives, or temporary memory like RAMs, right? So while storing it in RAM, the idea is that we need a temporary address to store it somewhere, right? So pointers are used to store the value of that address. So that when we are working with the variable, we can work over with its address also, right? So dynamic memories use pointer a lot. Okay, they enable us to simply call a variable by its address location, right? Because देखो जो नंबर है 10 20 डिफरेंट वेरिएबल में स्टोर हो सकता है, बट विच वेरिएबल आर वी एड्रेसिंग वो उसके एड्रेस से यूनिकली आइडेंटिफाई हो जाएगा, राइट? तो जैसे मान लो कि एड्रेस है 10, इसका पॉइंटर होगा इसका मेमोरी में, ठीक है, लाइक #25 जहां पे भी स्टोर्ड एड्रेस होगा, तो वो एड्रेस से भी इसकी वैल्यू निकाल सकते हैं, ठीक है? So let us check in C++ how can you do that. I'll just quickly work that around for you. So we'll do simply hashtag include one more library known as bits slash standard C++.h. Using namespace as this, we will create one function, simple function, void let's upgrade. Okay. The reason I'm making it void is because I don't want it to return anything. Okay. So currently, why it is showing the red line is because I didn't save my code after throwing an error to you, right? So Ayan Biswas is asking that why my C++ is throwing a red line error on compact SUVs is because if you see on the top of my C++, there's a white dot which says the file is not yet stored. If I click on it, will remove the error from the compact SUVs. Okay, so that's the current reason why that is happening, right? We will reload the code, it will go away. Okay, so let us create a variable, say variable 1 is equal to, let us look at anything like maybe 10 to it. Okay, now let us declare a pointer. This is how we declare a pointer. Okay, so pointer has to be of the same data type. If I'm using integer, it has to be integer, but with an asterisk mark. This is how C++ understands. This is the syntax by which C++ will understand that I am accessing a pointer. I can name it PTR1. PTR stands for pointer, but it's not a reserved keyword, just the way I'm naming it. Okay. Now, suppose if I have to find the address of the variable, तो वो मैं इसमें स्टोर कर देता हूँ. PTR1 का एड्रेस कैसे एक्सेस होगा? It will be and ampersand के साथ variable semicolon, and this is how I'll be able to find the address around PTR1 के अंदर स्टोर हो गया है, right? I'll also comment it out. Storing the address in var1, oh sorry, PTR1 of var1 variable. Okay. Now once this is done, we'll just simply see out different things so that you can see what it is. See, value at PTR1 is equals to, what is the value? This PTR1, I'll just print it out for you with a /n. Value of, let us say, variable 1 is variable 1. Value of, remember this is a little bit confusing, but only for day one. If you understand it correctly, it is never confusing ever in life. I'm adding asterisk right before the name of the variable. It works opposite, right? It prints out the value to me. So I'll go ahead and add asterisk right over here, and it will give back the value to me. Let us see how it is supposed to work. In the main, I'll just go back and remove this. Okay. I'll call my function over here. And I'll mention maybe my function name. Let's upgrade semicolon. And fair enough. Okay. Return 0. Let us put it. So as Ayan wanted to understand, now that we have compiled the code again, you see that red line has now disappeared. Okay. And you can see that PTR1 actually holds the memory address, which is 0x5FFE94, which is the memory address at where the variable 1 is stored. And adding an asterisk before it gives us actually the value of that address, right? So that's how it works. Okay. देखो variable one जो है variable one it is storing the value and ptr1 is storing the address of it, है ना? So for example what will happen is इसको इस तरीके से समझ लो कि I am a stranger, okay? I am a stranger meeting someone, ठीक है? जैसे for example you all are meeting me here, so you all know कि मेरा value is at YouTube पे मैं live में आपको मिल जाऊंगा, ठीक है? But what if I change my location and now I'm at a very different place, ठीक है? अब यहाँ पर you don't know exactly where I am, right? So basically if you know my memory address, so you can go and check on that memory address कि अब यहाँ पर क्या बैठा है. You will see there is an updated person right over there and वो आपको updated person मिल जाएगा, right? So क्या है basically pointer is actually storing the value of address. तो एग्जैक्टली इस एड्रेस पे अगर आपको आके देखना है कि व्हाट इज हैपनिंग एट दिस एड्रेस, अगर कोई वैल्यू चेंज भी हो गई है, मान लो वेरिएबल वन की वैल्यू चेंज भी हो गई है, बट ये एड्रेस पे क्या है, इट विल ऑलवेज पॉइंट टू दैट एड्रेस, राइट? यू कैन ऑलवेज पॉइंट बैक टू दिस एड्रेस एंड सी यहाँ पर हो क्या रहा है. So that's basically a pointer. Pointer has nothing to do with value. वहाँ पर 10 बैठा है, 20 बैठा है, 30 बैठा है, उसको फर्क नहीं पड़ता, वो एड्रेस से बात कर रहा है. आज इस एड्रेस पे मैं रह रहा हूँ तो वो मुझे पॉइंट कर रहा है, कल चल के इस एड्रेस पे कोई और रह रहा होगा तो उसको आगे पॉइंट करेगा वो. डू यू गेट दैट पॉइंट? That's the logic how it's supposed to work. Pointers map or show you or point you towards the address in the memory location, right? So that's basically how things are supposed to work. And there are different ways that we can call these addresses. Let us check that out. I'll quickly show you a code for it. Just understand how we can pass values by just by values, right? So we will pass by the value. Okay. I'll need a function. So function, देखो function क्या होता है? Function समझते हैं. See, function is a block of the code जो सिर्फ तभी चलेगा जब उसको बुलाया जाएगा. A function is a part of code which will only run when it is called. Okay, so that's the point. Suppose if I'm creating a function which is supposed to return integer, I explained a little bit about functions that function what it is supposed to return should come here. If it is not returning something, void works. Okay. Suppose if I return a function which is supposed to do squaring of something, right? Square square one. Suppose it takes any integer n, okay, and this is what it's supposed to do. So I'll take cout. Address of n1 in square one function is, I'll print the address of n right over here, okay? Just to show you that what exactly is the n representing over here, the address of n, right? And what we will do is we will do let n be multiplied by n itself, right? So n will be incremented by n, मतलब n square हो जाएगा, and we will return the n square, okay? All right. Now we will create a void square 2. Now here we will pass the variable by reference, okay? Pass the variable with reference of pointer. Integer n, okay? So this is how you will understand, right? Asterisk लगाना जरूरी है अगर pass by उसका address pass करना है तो, okay? Let us go once again into it. cout करेंगे address of n2 in square 2 function is basically equals to, we will just simply print n over here with a slash n, and we will derefer it. तो हमने पहले उसको रेफर किया था, derefer कर देंगे एक और स्ट्रिक लगा के, राइट. So what we will do is के n की जो वैल्यू है, क्योंकि देखो in line number 14 the thing that we are taking input is not a value, it is an address. तो उसके आके वापस स्ट्रिक लगा दोगे तो एड्रेस की वैल्यू कन्वर्ट कर देगा. So that value, okay, it should be multiplied by the value at n. Okay, that's dereferencing part over here. Dereferencing part. Okay, that's it. But we are not returning it at this point. Okay, we are not returning it. Remember that. And okay, my semicolon went away with the comment. Now it's fine. And what if we now refer by reference, right, of the AND argument? You can also check that. So let us create one more function, void square square. Here we will take integer and we will use AND ampersand, right, n. Then what we will see is right over here that cout address of n3 in square 3 function is, we will print the address slash n, and we will again do the multiplication right over here. And once we are done, we will create the main function. Let us create one function, say void let's upgrade. Here we will take a variable, say integer n1 is equals to, say, any value like 4 for an example. We will do cout address of n1 in main block is equal to, we will print the address of n1 slash n cout square of n1 is equals to, we will call the square one function. Okay, remember what it does. We will pass the direct value of n1 into it. It takes the direct value of it slash n. Okay, and cout no change in n1. Okay, we will print the n1 once again slash n. Okay, and then what we will do is, we will create an integer main function. We will call the LetsUpgrade function and return 0. Only to check what's cooking in here is that address of n1 in main is 0x5ffe, and once we enter the square of n1 function, we realize that the address still remains same and the value becomes 16, but there is no change in n1. How does it happen? Now let's go back and check our n1 function. Okay, so how will this code work? First, let's start from that point. Okay, this code will start from line number 33, which is the main function. It will enter into it. It will realize, oh, okay, I have to enter one another function, which is at line number 34. It will find that function LetsUpgrade is right over here. Okay, in that function, it will find line number 27 is a variable that I'm declaring n1. It will find that. Fine, I'll store a value 4 over there. It will print the address of it using and n1 to it. Once it has done that, it will go, and now line number 29 will call square one function. Let us jump to square one function. So once it goes into the square one function, let's just see out something. What is that? Address of n1 in square one. Okay, so you remember that we are taking a value with a different variable name now. अब इसको हम n बोल रहे हैं. I can also call it x, no problem. और यहाँ पर मैं x भी लगा दूँ या n लगा दूँ, it doesn't matter, क्योंकि हमने declare किस में किया था? We declared in n1, right? And it still works the same way even for n. The same address. So what does it mean that a person can have 2-3 different names to it, right? Like I can be Gaurav Deep for someone, or I can be GD for someone, or I can just be G or just Gaurav for someone, right? But all these 3-4 names are coming back to the same biological person, that is me. So similarly, जो main function में n1 था और जो square one function में n है, they both are mapping back to the same address, the same physical entity. In the next line, what I'm doing is basically I am doing the n square in the square one function and returning n. So square of n1 यहाँ पर जो return आ रहा है उसमें print हो जा रहा है, but it is not storing it anywhere, right? It is not about storing it anywhere. If you see, it didn't store it on n, it just returned the n square, है ना? And once it returned that n, it didn't impact n1. n1 पे impact नहीं आया, n1 की value still 4, वो n पे impact आया, right? So that's how dynamic memories work and how they're allocated. This is a very good example to understand that how dynamic memory works, right? This piece of code will be very useful to learn it. Now let us go back and do n2. एक और variable बनाते हैं n2. Let us say with the value 4 ही रख लेते हैं. Let us see out address of n2. Meanwhile, just a small feedback, students. If my voice is still clear, my net is working fine, please put it in the chat. All good, okay? Just to make sure that my internet is working fine, because it's been a while that no one has put any chat. So I'll be waiting out if some chats come in. So all of you be a little proactive and just quickly throw in chats that are we still following up? It will make me doubt more and more that I'm losing my voice. All right, so we will do. Now what we're doing is we will change line number 33, that address of n2 in main. We are printing that. Then we're calling out the square 2. We will go and check square 2 once again what it does. Then we will print square of n2 like this, n2 slash n, and then we will do a change reflected in n2. Let us also see out that. Slash n, okay. So address of n2 is same in main function, and so is in the square 2 function. Square 2 n2 is 16, and if you see that the value of n2 is now changed, it now holds 16. वो 4 चला गया उसके पास से. What happened in square 2 is that you can see that we are actually are dereferencing and storing that value over there, right? So that's the correct idea, and this code is definitely the piece that will help you understand how pointers work, how dynamic memory works, and how it's supposed to work, right? So again, I will iterate. So how do we basically create a dynamic array? Now let's try to understand that. So we have to create a dynamic array. The syntax is like this, right? Syntax of dynamic arrays, okay? If there is any doubt, you can definitely throw it in. We do the data type. जो भी data type होगा, int होगा, float होगा, we use a asterisk in front of it because it is dynamic. We will use a pointer जो भी पॉइंटर का नेम होगा इज इक्वल्स टू द मेन कैच और द मेन रेसिपी इंग्रेडिएंट इज दिस न्यू। न्यू से पता चलता है कि ये एक डायनामिक एरे बनने जा रहा है। इसका डेटा टाइप जो भी होगा, इंट होगा, फ्लोट होगा, एंड देन द एरे साइज टू बिगिन विद, राइट? नहीं मेंशन करोगे इसमें तो भी चलेगा, बट दिस इज हाउ डायनामिक एरेज विल बी असाइन्ड टू डू इट ना। So I'll simply show you a code to do that. You can see namespace include किया, main में गए, enter the size of the array, cout से value ली, integer size, okay, in लिया, size के अंदर store किया. This is the syntax that I'm talking about, right? Data type with an asterisk, variable name equal to new integer, उस size का बना दो, और वैल्यूज इन दिस साइज आप उसमें ऐड करते जाओ, ठीक है, और उसको प्रिंट कर लो, बट द आइडिया इज बाद में आप उसको डिलीट कर सकते हो। तो डायनेमिक एरे में से चीजों को निकालना है, डिलीट कर दो, एलोकेशन या उसकी इंडेक्स वैल्यू पे से चीज डिलीट करनी है वो भी कर सकते हो, मेमोरी में से रन टाइम में हटाना है तो भी हटा सकते हो, एंड दिस इज द मेन आइडिया एंड हाउ वी कैन वर्क विद डायनामिक एरेज, राइट? सो दैट्स हाउ इट वर्क्स। वी कैन कीप ऑन, इसमें कल चल के मान लो आप ग्रैंड विटारा ऐड करनी है, बड़े एसयूवीज पे जाना है, फॉर्च्यूनर ऐड करनी है, एंडेवर ऐड करना है, और ये रियल टाइम में होना चाहिए। मतलब मैं स्टार्टिंग में बता नहीं पाया कि साइज क्या होना चाहिए, तो डायनामिक एरे कैन हैंडल दैट फॉर अस, राइट? So that's how the dynamic things work, or new or delete keywords हैं which will help us understand how to store the arrays and how to handle them in real time. Okay, so for now I will rest the session over here, that we handled the dynamic memory allocations, we handled the pointers, we learned what are arrays, and now we are good to go starting from tomorrow to learn about linked lists, right? How linked lists differ from array, different type of linked list, doubly linked list, singly linked list, circular linked list. Okay, we will understand this data structure in thorough depth. We will understand what is recursion. So make sure that tomorrow's session will be engaging for all of us, that we all join in quickly and be on time so that we do not miss anything on the data structures that we will be talking about. I hope the first data structure of array is clear to you, and how the array can be dynamic in nature is clear to you. With this, we can rest the session, and let's end or close today's class right over here. Thank you so much for joining in. Tata, bye bye, sayonara to all of you.